Dear students, today we will start with the topic of types of sampling. But before going to see what is types of sampling, we'll see how samples are produced. So here I have shown a circuit for sampling process, a simple circuit which is having only an electronic switch. And the input to the circuit will be an analog signal as we have shown here, xt. And the output of the circuit will be samples. Samples means they will be like your pulse amplitude wave. Now here, this input is given here, and here you are having an electronic switch. This electronic switch will change its position from point 1 to point 2, point 2 to point 1. It will go on changing its position from point 1 and point 2 at a frequency rate called as Fs. Fs will be the frequency rate, and this Fs rate should be greater than or equal to 1 upon time period Ts. Now that time period is the time period between the pulses what you are going to get, between the samples what you are going to get. The time period between the samples is called as Ts. Now whenever this switch is connected to point 1, a part of this input will pass through the circuit, and whenever it comes to point 2, there is a gap, there is no input passing, the input is stopped. Whenever it comes to point 1, part of it goes. Whenever it comes to point 2, the circuit is stopped. So whenever it comes to point 1, a small sample of the input signal will be allowed to pass for a time period tau, which will determine the width of the pulse. So for this width of the pulse, this will be connected to point 1. The switch will be connected to point 1. And again, when it comes at the end of the width of the pulse, it will come to point 2. So from here to here it is coming. So this is a sample. So from here it is point 1. It is going to connect. And from here till here, that is the width of the pulse, whatever you have, that is for tau seconds, it will come till here, and at this point it will come to point 2. At this point it will come to point 2. So once it comes to point 2, there is a gap. There is no sample between that. And afterwards, when again it comes to point 1, the next sample is produced. Like this switch will come from point 1 to point 2, point 1 to point 2 at a frequency rate Fs, which is greater than or equal to 1 upon Ts, where Ts is the time period between two pulses. The time for how much it is connected to point 1 will decide the width of the pulse. It will decide the width of the pulse, whether you want a smaller width or the larger width, that will be decided till it is on point 1. But once it comes to point 2, the width of the pulse is over. So the sample comes out only when the switch is connected to point 1. When the switch is connected to point 2, there is a gap between the samples. Okay, so this is how an analog signal is converted into samples by a simple process of electronic switch. Dear students, now we will see what are the types of sampling. Now as I have shown you here, the basic two types of sampling is, the first one is called as instantaneous sampling, ideal sampling, and the second one is called as practical sampling. In ideal sampling, the pulses of train which is used to sample the analog signal are impulses. They are not pulses with width, they are just impulses. And this is a theoretical sampling. This is an ideal sampling, which cannot be practically possible. Then once we come to what do you mean by practical sampling, in that there are two types. One is called as natural sampling, and the other one is called as flat-top sampling. In a natural sampling, the amplitude of the sample will go along with the analog signal. And in flat-top sampling, the amplitude of the sample will sample and hold at the first point it reaches the amplitude of the analog sample. So there it will hold at that first position, and it will not vary according to the amplitude. So this one is called as natural sampling, and the second one is called as flat-top sampling. Dear students, now we will see the first type of sampling, which is called as instantaneous sampling or ideal sampling. Now, as I have shown here, This is the analog wave, which is going to vary like this, and that analog wave we want to convert it into samples. So to do that, we require a train of impulses. Now these are your train of impulses. They are not having any width. These are train of impulses. They are spaced at regular time interval. You can see here 0 to t years, 2 t years, 3 t years, 0 minus t years, minus 2 t years, minus 3 t years. So they are equally spaced. They are having a constant amplitude and they don't have width. They are impulses. Now when you multiply the analog wave by these impulses, you will get something like this, where the impulses amplitude will vary according to the analog signal. So here you can see the impulse at 0, which was so much, has to take this amplitude, and it has taken that amplitude over here. So similarly, the impulse at t years, 2 t years, 3 t years, and here minus t years, minus 2 t years, minus 3 t years, all will take the instantaneous value of analog signal amplitude. And this is how you can show your ideal sampling or instantaneous sampling. So this will be the first type of sampling, where it is called as ideal sampling, where the samples are only impulses. They are not pulses with width. There is no width for them. So they are only impulses. So this type of sampling is practically not possible. So it is called as ideal sampling. Dear students, now we'll see the second type of sampling, which is called as natural sampling. Now here if you see, this is our analog signal and these are the train of pulses. Now these are the train of pulses which are having constant width. The width is constant and the position is constant. So they are having time period t years between each pulse and their amplitude also is constant. Now when you multiply this with the train of pulses, that is analog signal multiplied by train of pulses, then we will get a pulse amplitude modulated wave in this way. Now here the most important point what we have to see is, every pulse will vary its amplitude according to the instantaneous value of this analog signal, but the top of every pulse, if you see, every sample if you see, it is varying as this amplitude is varying. It is not holding at one position. It is varying as this amplitude is varying. So here if you see, it is varying as that amplitude is varying. So everywhere it is varying as the amplitude is varying. It is not holding straight. It is varying according to the instantaneous value of the amplitude. So it is called as natural sampling. And here the time period is maintained as the train of pulses at t years. Even here you can see the time between two pulses is t years only. So in this way the time period is maintained and the width of the pulses are maintained constant. Only the amplitude is going to vary according to the variation of analog signal. So this is your natural sampling. Now here students, we'll see the third type of sampling, which is called as flat top sampling. The procedure is same as we saw in natural sampling. We'll be having analog signal xt. We'll be having train of pulses whose width, amplitude and position will be constant, and we are going to multiply them, and here we are going to use a sample and hold circuit. With that sample and hold circuit, what will happen is, whenever the sample is going to touch the first point of the instantaneous amplitude, then it will remain constant till the end of that pulse. Even here if you see, once it touches the amplitude of the instantaneous value, then it remains constant at that value only. It will not go along with the instantaneous value of the analog signal. Even here you can see it is coming and it is remaining constant and then coming down. Here also you can see it is coming here and remaining constant. Here also you can see it is coming here and remaining constant at that value. So because it is remaining constant at every amplitude value from the first instant to the last with the width, that is why it is called as flat topped. All these tops are flat. they are not going to vary according to the instantaneous value. They will remain at the first value what it has touched. There only it will remain constant for that width time period. For that width of the pulse, it will remain constant. So that is why this is called as flat topped sampling.